Dear leaders, professors, and colleges, my name is Yue Fang. My metric number is 23202239, and my topic is enhancing operation efficiency and customer retention rate of Taobao's e-commerce platform through customer segmentation and sales optimization. Okay, let's see next PPT. My content includes 6 parts. Part 1, Abstract. Part 2, Research Objective. Part 3, Research Question. Part 4, Methodology. Part 5, Results and Discussions. Part 6, Recommendations. Okay, let's see next PPT. Abstract. In today's highly competitive e-commerce environment, improving customer retention and operational efficiency has become vital for platforms like Taobao. This study aims to enhance user segmentation and retention prediction by integrating traditional RFM analysis with behavioral indicators such as clicks, favorites, and cat additions. Using a real-world dataset from Alibaba's Tianchi platform, we analyzed the 30,000 user activity records over a 9-day period and applied K-means clustering to identify distinct user segments. Retention prediction was conducted using both logistic regression and XGBoost models. The results demonstrate that XGBoost outperformed logistic regression in accuracy and interpretability, with favorites and cutting behaviors emerging as the most influential features. These findings suggest that the platforms should focus less on transaction value and more on behavioral engagement signals to build targeted, data-driven marketing strategies. The study provides us a predictive framework for e-commerce platforms seeking to reduce customer acquisition costs, increase customer lifetime value, and implement intelligent lifecycle marketing. Okay, next PPT. Research objectives. To construct multi-dimensional user profiles by integrating traditional RFM metrics with behavioral features such as clicks, cutters, and favorites, in order to better capture user engagement. To segment users into behavior-based clusters using K-means algorithm, allowing the identification of distinct user types such as loyal, silent, or hesitant buyers. To predict customer retention using survey-based learning models, specifically logistic regression and XGBoost, based on user interaction patterns during the operation period. To propose actionable strategies that enhance customer retention and maximize platform return on investment by translating analytic insights into targeted operational interventions. Okay, let's see next PPT. Research questions. 1. How can user behavior be captured beyond the transaction data? We examine how interactions like cutting and favoriting influence future engagement. 2. Can clustering improve user segmentation compared to demographic methods? Behavioral clustering helps go beyond age and gender to discover true engagement patterns. 3. What are the key predictors of user retention in e-commerce? We test which variables: reasons, frequency, cut, favorites, mattermost. 4. How can platforms apply prediction outputs to real-world marketing? We translate predictive insights into CRM and targeted reactivation strategies. Okay, let's see next PPT. For research methodology. A. Data collection. Alibaba Tianchi. User log for 9 days. Click, favor, cat, buy. behavior logs were collected from the Blindforce open dataset, and a total of 30,000 active users were random sampled for analysis. B. Future engineering. 6 variables including RFM, clicks, favors, cutters. We extracted key features that reflect the future intent and engagement. C. Clustering model. K means K is 4 to create behavioral segments. The user base was segmented into loyal, hesitant, silent, and browse heavy use. D. Retention modeling. Logistic regression with XGBoost. We tested 2 classification models to predict if a user will retain. Okay, let's see next PPT. 5 results and discussions. Cluster 0, silent and low engagement users. These users show minimal activity, an average of 3.5 clicks, nearly 0 cutting or favoriting, and no futures. They likely represent the first time of incidental visitors. Cluster 1, loyal high-value users. This group records the highest average futures frequency, 1.15, and strong engagement across all behaviors. With a low recency value, they are active repeat buyers and should be prioritized for retention efforts. Cluster 2, watchers with intent. Users in this group have the highest click, 7.96, and favorite, 2.61 rates, yet rarely convert. Their behavior suggests interest without futures, likely due to hesitation or price sensitivity. 3. Heavy browser no action. These users browse frequently, 9.47 clicks, but show minimal interaction beyond that. They indicate strong interest but lack convention motivation. Okay, let's see next PPT. Cluster behavior differences. As shown in the Figure 1, the user segments exhibit distinct behavioral patterns. Cluster 1 outperforms other groups in all key transaction metrics except clicks, showing high futures frequency, motor rate value, and actual buys, characteristic of loyal repeat buyers. Cluster 2 shows high levels of clicks and favorites but very low futures activity, reflecting strong interest without convention, typically of hesitant users. Cluster 3 has the highest click rate but almost no futures, indicating browsing-heavy users who may be price-sensitive or information-seeking, requiring better targeting through pricing and recommendations. Cluster 0 scores lowest in all behavioral dimensions, especially in transaction-related indicators, and represents the topic silent and low engagement group. Okay, let's see the next PPT. Cluster distribution in size beside on finger. Finger clearly shows the cluster 1, orange form a distinct and a concentrated cluster on the right side, indicating high engagement and behavioral diversity. This aligns with its strong transaction performance and activity participation. In concentrates, cluster 0, 2, and 3 are densely packed on the left, suggesting lower overall activity and less differentiation. Notably, cluster 2 and 3 show overlap, implying similar behavior in some aspects but subtle differences in others. The visualization confirms the validity of a clustering approach, particularly in identifying high-value users, cluster 1, and support targeted, differentiated marketing strategies. See the next PPT. Model comparison summary, XGBoost with logistic regression. Overall, XGBoost outperformed logistic regression across nearly all key metrics, demonstrating strong predictable and generalization. It achieved 66.5% accuracy, about 10 percentage points higher, and balanced precision 64.3% and recall 75.9%, resulting in a superior F1 score of 69.6% compared to 65.1%. Most notably, The AUC score for XG boost was 0.767, far exceeding logist regulations 0.616, indicating better classification of both retained and non-retained users, particularly in imbalanced scenarios. Figure 3 and 4 illustrate the ROC curves. The curve for logist regulation shows weaker separation and stay close to diagonal, while XG boosts the ROC curve rests stably toward the top left corner, conferring higher stability and precision. These results highlight XG boost's ability to model nonlinear feature and recommend it as the preferred integer for retain prediction in real-world deployment. These results highlight XG boost's ability to model nonlinear feature and recommend it as the preferred integer for retention prediction in real-world deployment. Okay, let's see the next PPT. Confusing metric insight, logistic regression with XG boost. Figure 5 and 6 show the computing metrics for logistic regression and XG boost, providing clear insight into classification performance. Logistic regression has significantly misclassification, particularly of negative class. Correlate predicts 951 positive cases, but misclassified 250 as negative, while incorrect labeling 769 non-retained users as positive. XG boost perform more balanced, correctly predicting 112 positives and 667 negatives, while misclassifying only 507 non-retained users. This shows better accuracy and lower error rates compared to XG boost's ability to balance positive and negative class prediction is crucial for retention forecasting, as it minimizes false positives and negatives, making it a strong model for real-world deployment. Okay, let's see the next PPT. Key findings from regressions and future importance. The regression results show frequency as a strong predictor of retention with a coefficient of 5.25, highlighting its significant positive impact on repurchase likelihood. Motoring and bias have negative coefficients, indicating multilinearity and potential model redundancy. Barriers and checks also show negative coefficients, suggesting that the higher interaction without convention clause 2 lead to lower retention. Recency and clicks have small negative coefficients, indicating minimal impact on retention prediction. In XG boost, barriers is the most important feature, 0.372, followed by cost and frequency, all reflecting key engagement behaviors. Bias and clears have low importance, while motoring has nearly no impact, indicating other features already capture the insights of the feature's behavior. Okay, let's see the next PPT. 6. Recommendations. Both convention from high intent behavior. Barriers and cats are strong retained predictors. Use personalized offers, time-limited discount to convert class 2. Customize promotions during intent windows, driving higher conversion. Maintain high-value loyal users. Offering loyalty tiers, exclusive reward, personalized experiences. Tiered loyalty system extend user life cycle and advocacy. 3. Re-engage silent users. Send personalized reminders or couples based on dormant behavior. Early behavior checks predict churn targeted reactivation work. Increase features frequency and repeat behavior. Frequency has strong positive correlation with retent. Use gamified reward, multi-stage incentives during content. Buy 3 times get bonus, boost long-term engagement. 5. Guide users through clicks and favorites. Clicks and recency are weak predictors alone, but useful for intent mapping. Trigger retargeting based on click favor behavior within key time frames. Click-based signals enhance recommendation accuracy. 6. Rethink motoring as a value indicator. Motoring value and had almost no predictive power in XG boost. Focus on engagement dips. No spending value. Use behavior intent combination for smart segmentation. Okay, that's all. Thanks for listening.